In the 7.6 Go, you're going to be finding the distance and slope. And these are all going to be done the same way. Now, because it's not from a graph, the way you're going to find the slope is using the slope formula. The slope formula is the change in y over the change in x, also known as y2 minus y1 over x2 minus x1. To find the distance, we'll use Pythagorean theorem. Now, you're going to use the numbers from the slope that were the unreduced numbers, the numbers that you originally get out of the slope formula, not the reduced numbers. So if one of the slopes reduces, don't use the reduced numbers because that's not going to be the full length of the segment. So we'll use the slope formula to find the slope, and then we'll use those numbers to find the distance using Pythagorean theorem. So let's do a couple examples. So the first one here, we've got the points negative 2, 8, and 3, negative 4. The change in y's would be negative 4 minus 8 over the change in x's, which would be 3 minus the negative 2. Now be careful about the double negatives. So again, negative 4 minus 8, the back point minus the front point, and we're just going to go in the same order. For the x's, the back x, which is the 3, and the front x is the negative 2. Now that double negative becomes 3 plus 2. So up top, negative 4 minus 8 is negative 12. On the bottom, 3 plus 2 now is 5. So we get negative 12 fifths. Okay, this one doesn't reduce. Now when you do Pythagorean theorem though, you're taking those numbers and you're popping them in. Those are basically the rise and the run, or the vertical and the horizontal legs for the right triangle. The negative though we don't use. That when we talk about a distance is always a positive number. The negative for that 12 just means it goes down. The length itself, though, is 12. So when you're popping numbers into Pythagorean theorem, they're lengths which are always positive. So we're just going to say the legs, 12 and 5, are popped in. So it's 12 squared plus 5 squared is equal to the x squared. When we substitute in, this is what we're going to get. Again, don't use the negative 12. Technically, if you put it in parentheses with the negative 12, it would work. If you don't have the parentheses, it would not work. But again, these are lengths. Lengths are always a positive number, so don't worry about the minus sign. Just substitute in the positive values. So 12 squared is 144, 5 squared is 25, added together x squared is 169, but we don't want x squared, we want just x. So we'll square root both sides. You can use your calculator if you don't recognize it. This actually is a perfect square, that the distance turns out to be 13 units. Now let's pick an example of one that actually does reduce. Number 10 actually would reduce if we look at this one. That if we use the slope formula, the change in y over the change in x would be 5 minus the negative 3 over 1 minus the negative 7. 5 minus the negative 3 would become 5 plus 3, or 8. And 1 minus the negative 7 becomes 1 plus 7, which is also 8. 8 over 8 is 1. This one has a slope of 1. Now when we do our distance, though, we don't want to go 1 squared plus 1 squared. That wouldn't be the length of the whole segment. The whole segment went up 8 and over 8. Those are the numbers we want to use in Pythagorean theorem. So again, make sure you justify. Substitute in your values. 8 squared plus 8 squared equals x squared. 8 and 8 were the legs, which is 64 plus 64 is equal to x squared. Added together, x squared equals 128. And we'll take the square root to find x. Now 128 is not a perfect square, so we're going to need the calculator to approximate. When we approximate, make sure you use the approximation symbol. And for my class, you round to 2 decimals. We'll round to the 100th. So I'm going to say x is about 11.31 units. Now you're going to do the same thing for the other 4 problems. Find the slope and find the distance. For the slope, use the slope formula. For the distance, use Pythagorean theorem. Keeping in mind, the numbers you're using Pythagorean theorem are the unreduced numbers like we just did for the slope. All right, good luck on the rest of the go.